Inverse functions log review. Well, the first part, remember, is just functions in general. Like if I gave you this, we'll say this. And I wanted you to do different operations with them. Like if I said f plus g of x, so remember you're looking for an expression. You're just going to take f, which is 6x plus 3, plus g, x squared minus 4, add like terms, x squared plus 6x minus 1. Same thing as minus, let's say f minus h of x, so same thing, looking for an expression. Notice how on this one, you're going to subtract h, but think about it as being in parentheses. So it'd be not just 6x minus 2x, but it would also be, when you change the signs, plus 10, because you would change signs to both. Then, of course, multiply, let's say fh. That would just be x plus 3 times 2x minus 7. So 12x squared minus 42 plus 6 minus 21. So negative 36x minus 21. And last but not least, let's divide. Let's say h over g. We haven't done that yet. Still remember x, so looking for an expression. H over g. That's all you can do. You can't reduce because nothing goes into all four terms, so you're done. Now let's say, for instance, that you wanted to find f of g of x, which is the same thing as this. All you're going to do is plug in g, your g expression, into your f expression. So if your g expression is x squared minus 4, you're going to plug it in. So 6 times x squared minus 4 plus 3. A little bit of distributing. Add like terms. There you go. Now look at the difference. Let's do g of f. If I did f into g, you're going to have 6x plus 3 squared minus 4. So we're going to have to do the full method. So 36x squared, 18 plus 9. Bring down the minus 4. 36x squared plus 36x plus 5. So that's the difference. And so that is all if you're taking it and it's an expression. Now, if it's a number, you actually just plug it in. So if I did something like g minus h of 2, you literally just plug 2 into g. So 2 squared minus 4, 0. Plug 2 into h. 2 times 2 minus 7, negative 3. So 0 minus negative 3, 3. If you wanted something like, let's say, h of f of negative 1, same thing, negative 1 into f. So 6 times negative 1 plus 3, negative 3. And then plug negative 3 into h. So 2 times negative 3 minus 7, negative 13. So that's just operations of functions. Remember, if it has an x there, you're looking for an expression, if it has a number there, you're looking for a number. Moving right along. Now let's do some inverse functions. Make sure it's all lined up here. All right. Let's say if I did y equals 5x plus 12. If you want to find the inverse function, now remember, if they just give you coordinates, you can just flip them. So like, let's say that's f of x. The inverse would just be 4, -1, 3, 2. But if they give you an expression, y equals, or even f of x equals, remember you make it y, and then you're going to always do two things. Switch the x and y, solve for y again. So if you switch them, you literally get that. And now to solve for y, subtract the 12. I always like my variable on the left if possible, so I just flip the whole thing, so you're good. Then divide by 5 to solve for y. So inverse equals x minus 12 over 5. Let's even say I did x squared minus 8. To find the inverse, switch x and y. Of course, add the 8. So y squared equals x plus 8. Square root. So inverse equals square root of x plus 8. You could even say square root of x plus 3. Switch x and y. Square both sides, so x squared equals y plus 3. Subtract the 3. Now, I know this is a parabola. Technically, this one, to make it have an inverse, you would need to restrict it and say that x is greater than or equal to 0. But we'll get to that in a second when we graph it. I'll show you on that one. Now, if you want to find the inverse by graphing, remember, like in this case, that's a terrible one. Let's do a nicer one. 3x plus 2. So if you go up 2, up 3 over 1, there's your line. Now the inverse, you always graph the line y equals x, and it's always going to be symmetric about that line. Now you can kind of eyeball it, see how it crosses there, and know there's going to be your inverse, or remember the coordinates. So if this is 0, 2, that means 2 zeros on there. Here we had 1, 5. So on the inverse, 3, 4, 5, 1. And there you go. Now let's even say this one. These are the ones I'll show you that you have to restrict. Because see, if you say x squared minus 8, that's down 8. And you know, a parabola. Well, the trouble is, if you do your line and you make it, the inverse is not going to be a function, and we don't want that. So all you have to do is restrict it so the domain is x is greater than or equal to 0. And now you can graph it just starting from there. So if 0, -8, that means -8, 0. It's going to cross about right there. There you go. There's the inverse. Just like with this one, notice how x squared plus 3 is that. So to find the inverse, if you've got -3, 0, 0, -3, it's going to cross about right there. There you go. Which x squared minus 3, down 3 in a parabola, so see how I just would have restricted it. Most of the time, though, if you're just looking for inverse, swap x and y, solve for y again. Now, let's say graphing exponents. Remember, if you have y equals 2 to the x, the easiest thing is to plug in a few points. Anything to the 0, 1, 2 squared, 2 to the first, 2 squared. So 0, 1, 1, 2, 2, 4. There you go. Remember, if it was something like -3 to the x, if you want, you can still do 0, 1, 2. You can plug in anything you want to. 0 power, -1. First power, -3. Second power, -9. So 0, -1, 1, -3, 2, -9. Notice how it is below. If you have fractions, remember they are generally like this because they're exponential decay. Number greater than 1 to the x power, exponential growth. Then if you wanted, let's say, domain and range, domain on this one, of course, all reals, but your range greater than 0. This one's still domain all reals, range y is less than 0. This one, of course, is the same as that. Remember, if they wanted you to shift it a certain way, you could do that by, you could still plug in the normal. You could do 0, 1, 2, and just see what happens. The 0 power, 1, plus 2, 3. 2 to the first, or I'm sorry, 3 to the first, plus 2, 5. 3 squared, 9, plus 2, 11. So 0, 3, 1, 5, 2, way up there, 11. So notice how you literally took this graph and moved everything up 2. Domain is still all reals. Range, y is greater than 2, because instead of 0, you shifted it up 2. Well, I'll stop there, and we'll actually do logarithms on this separate video, because don't want to make it too long. I hope this was of help to you. Have a great day.